In this short video, we'll explore how to find the derivatives of the inverse functions. Well, let's look at the relation between a function and its inverse. So if you compose the inverse functions to a function itself, you will get the independent variable out. So the f composed of f inverse of x equals to x. Now we're gonna apply the derivative to both sides. So we differentiate both sides of this equation. Take d over dx of both sides. On the left side, because we have a composite functions, we can use a chain rule to find this derivative. It will give you the derivative of the outer function, which is f prime of f inverse of x, multiplied by the derivative of the inner function, which is the derivative of the inverse of x. And on the right side, you have, d over dx of x equals 1. So as the goal is to find the derivative of the inverse, we divide both sides by the derivative of the outer functions. And that will give us the formula of finding the derivative of the inverse of x, given the function f of x. Well, now we're going to look at a couple of examples of how to find the derivative of the inverse of some of the trig functions. Let's start with arcsin of x. We know that arcsin is the inverse of sine of x. Then using the definition above, we can conclude that the derivative of arcsin is 1 over cosine of arcsin of x, because cosine is the derivative of sine. But we can simplify this derivative a bit further by using one of the trig identities. Cosine square x plus sine square x equals to 1. So you can solve for cosine x equals to 1, square root of 1 minus sine square of x. Replaces to get to this term. And then we know that sine and cosine can be cancelled out in the composite form. So then that will leave us with just 1 over square root of 1 minus x squared as the derivative of arcsine of x. How about arctangent of x? Arctangent is the inverse of tangent of x. And again, using the definition above, we can find that the derivative of arctangent equals to 1 over secant square arctangent of x, because secant square of x is the derivative of tangent of x. Using another trig identity, secant square x minus tangent square x equals to 1, we can replace secant square by 1 plus tangent square of arctan of x. And again, tangent of arctangent can be cancelled out. That will leave us the derivative of arctangent x equals to 1 over 1 plus x squared. So using these definitions, same methods, we can find the derivative of the 6 inverse trig function s below. We found arctangent of x equals to derivative of arctangent equals to 1 over x squared. Derivative of arcsine equals to 1 over square root of 1 minus x squared. And we can find that the derivative of arcsecant equals to 1 over square root of x times square root of x squared minus 1. And the derivative of arccotangent is similar to arctangent, but with a negative sign. The derivative of arccosecant is similar to arcsecant with a negative sign. And the derivative of arccosine of x is similar to arcsine of x with a negative sign. All right, here's how you can find the derivative of some of the inverse functions.